still not known what they can do and what they can't do. But during the building of the Panama Canal, deaths to yellow fever was quite high, and it was in the 1900s that Walter Reed demonstrated for the first time that mosquitoes can transmit yellow fever, and that was the first time that insects was implied as the vectors or viruses. And also for that reason, one of the reasons why Onderstepoort was built in Pretoria and in the area where it is at the moment was due of a high incidence of African horse sickness in the area. And people, for after Walter rediscovered in 1900, people for the next 20, 2, 3 decades, 20, 30 years, trying to show that horse sickness is transmitted by mosquitoes. Because the picture of horse sickness occurrence, they get infected at night, it is not transmitted from horse to horse. They were always thinking that an insect or a night active insect was involved. And when this guy showed that yellow fever can be transmitted by mosquitoes, the people at Onderstepoort at that stage also concentrate to show that mosquitoes can transmit African horse sickness. And the results wasn't very convincing until the TUE came along in 1944 and collect, together with the mosquitoes in his light traps, you also collect some Chilicoides biting midges, and we see that they are also blood feeding, and we feed them on a sheep which was circulating virus. 2-3 days later, we feed them on a healthy sheep, and was the first person in the world to show that viruses, and the blue tongue virus, especially at that stage and later on also horse sickness, can be transmitted by Chilicoides midges. So, as I say, know your enemy. What must you know about them? You must know, for each vector, which genera at least is involved, and which species in this genus can be involved. Know as much as possible about the biology of the species and pathogen involved. Know the geographical distribution, the seasonal abundant patterns, the life cycle of a vector and the pathogen, the infective stage, what stage is responsible, and the larval development site, resting sites, host preference, activity cycles, and, as I say, as much as you can. And what transmission mechanisms are also present. So Chilicoides control as a vector of a vector-borne pathogen transmission. Chilicoides have a near worldwide distribution. It's only absent in Antarctica, New Zealand, I think, beyond New Zealand. So it's a near worldwide distribution. At present, there's more than 1,366, we can make it 1,400 described species, and out of each species, more than 75 viruses have been isolated. If we just look at the most important Chilicoides-borne viruses, for equines, as you know, it's African horse sickness and equine encephalosis virus. For ruminants, your bovines and your sheep, it's blue tongue, episodic hemorrhagic disease of deer, which is especially in the Americas of importance, Akabani, and most recently Smolenberg, which was isolated in Europe, which is also present. I think Smolenberg was a couple of months isolated in Mozambique. And for humans, Chilicoides can transmit Orokuchi virus, but that's more in South America. Identification. What do they look like? There's a bottle of midges circulating, which you can see. And most people, most farmers, a lot of people, we are collecting midges. Though, yes, there's a lot of midges all over my farm. And everything smaller than a housefly or a mosquito is sometimes referred to as a midge. It's actually a very specific midge. It's night active, and things that I get confused with is this medium of your blackfly species, your sandflies of your phlebotomys species, and the leptoconus species, which is a day active midge, even with a hornfly or the hematopa species, and as I say, your sandflies. So they are very small, less than 1 to 2 millimeter in size, and night active, and not really very visible. And as I say, we can collect up to 1 million midges per night at the horse stable with one light trap, and you won't even notice them around. In South Africa, they don't bite people. although not very active in biting people. But still they got the Afrikaans name of brandasses. But in my, how long did I say I worked? 20 to 30 years?
34.
I was bitten by killicoides about 2 or 3 times. So in South Africa, they don't really attack humans, but it's quite a different story in Europe and in Scotland, where, especially Scotland, their species there is quite active in biting people, much more abundant than our species, and it is more a tourist problem and a human problem, biting problem, not a virus or disease pathogen transmission problem in that area. In South Africa, we've got at least 250 species, or done 200 species, with 20 which you can find very commonly around to animals. The most important ones is the Killicoides unicula. If you collect near animals, that species will make up to 90% of your specimens you collected. Other species you find here, some of them are bird feeders, like these two here, the Picmosticus and the Distinct. And the other one which can be important is your Killicoides polutinos, which is the near second most abundant species in Africa. And for a couple of years, that one is now a species for the last 20 years. Before that, it was grouped with Unicula, and this one is breeding in cattle dung, and Unicula is breeding in wet soil. So, but for a couple of years before the taxonomy did their work, this was actually a single species. If you look at the life cycle, there's a typical insect life cycle. Your male and females mating. Only the females feed on blood to develop the egg, like mosquitoes. So it's only the females which are blood feeding. They lay their eggs, 4 larval stages, turning into a pupae, which is back to the adult again. The cycle in the horse, you get your viremic horse, which is circulating the virus. The midge feed on it. After 4 to 20 days, the virus must first grow or replicate inside the midge before it can transmit the virus. So after feeding on a viremic horse, the virus multiply inside the midge and are transmitted to a susceptible horse. And this horse will develop viremia and circulate the virus for 2 to 4, even longer, before it forms antibody and the virus actually can go to low levels inside the horse, and it won't be able to infect midges anymore. The hosts, as I say, 200, 150, 200 species in Africa, and they are vicious blood feeders, and they can feed on the different species, feed on anything from other insects, like there's some females who will even steal the blood meal from blood-fed mosquitoes, up until the species who feed on animals. In South Africa, it's a group of worldwide actually. Killicoides are not very host specific, and mostly you can divide it into your bird feeders and your mammal feeders. There's not a difference, or there's no species linked to a specific animal group. So there's not specific species will feed only on horses or only on sheep. You only get your mammal feeders and your bird feeders. On the one hand, that is good news for horse sickness, because if one species is supposed to transmit it from a viremic horse to a healthy horse, and every second feeding is on another animal, your chances for transmission is a bit lower. But if it only feeds on horses, of course, every time it feeds on a horse, it has a chance to transmit the virus. But on the other hand also, if it feeds on a variety of animals, it can pick up a variety of viruses which can be transmitted with subsequent feedings. These midges can be very abundant, and we can collect up to more than 1 million, up to 1.5 million midges in a single night in with an honest-to-work light trap in a single night. So, and we don't know how efficient this honest-to-work light trap is even, and how much of a population we collect, but I deemed it's very low, because you can put up the light trap night after night. We use about 4 or 5 of them at honest-to-work per night in the season, and you don't get any reduction in the numbers. So the light trap actually have no impact on the numbers, and I think the percentage sample of a light trap is very low. So, and of course, if you have high abundance, you can always counteract the low field infection prevalence. Okay, as I say, we've got a number of species in Africa. Which one of them are important, or which can transmit the virus? Can all of them transmit the virus or not? For a long time it was thought that you get specific, especially for blue tongue, an EPI system was proposed, that the serotypes of blue tongue in Africa, or in the Africa subcontinent, will be linked to African chilicoidal species. You'll get your American blue tongue serotypes linked to American chilicoidal species in a different system working in Europe. And which of Antimicula, as I say, the most common species, or the abundant species in Africa, was thought of as the only blue tongue vector, and also the only horse sickness vector in South Africa, or in Africa. And one of my things I started when I started Onderstepoort was to see what of other species is susceptible to a virus and what species not. So first of all, we collect them alive with a light trap, not in the liquid this time. We separate the live niches. We put the live niches in a black box where they come to the light. Now we got them in a paper cup there, and we put them in a very primitive blood feeding membrane, which is just a blood there, a pill bottle there with the niches inside, and the chicken skin membrane on the bottom. Put them in a water bath up to about 35 degrees, feed them, keep them, okay, sort the blood feds under a microscope on a chill table to keep them cool, or to keep them immobile. We incubate them for 10 days at 23 degrees, and we see what percentage of the virus, of the midges, are still infected with the virus and what not, by microtutation and virus isolation on cell culture still at that time. And we also type the serotype which we get back. And so, from the 20 species, more than 13 species have shown to be susceptible to a virus. They can become infected with a virus and multiply the virus. And what we haven't shown is that all that species can transmit the virus in the end. As I say, some of that species which is susceptible to the virus is actually also considered as bird feeders. So they are susceptible to blue tongue and African horse sickness, but how often do they feed on horses, and what's the chances that they can transmit the virus to a horse from one horse to another? That will be determined partly by the host preference, which we are not even sure of, but it's shown that susceptibility to virus infection is not linked to one or two species, but it can actually be quite widespread in the genus Chilicoidus. And that makes, of course, to work out the epidemiology of these a bit more difficult and complicated. The average blood meal, we've also used that method to determine the average blood meal size for a Chilicoidus, and for Echinacea it was determined as 0.045 microliter. And theoretically, very theoretically, the implication of that is that you need a virus titer of at least 5 logs in the blood meal, in the animal, of an arabic animal, before it can transmit, or before a single midge will pick up a single virus particle or a single infective dose. And that is also for some reason, or partly the vaccine production is based on that. As I say, it's a live attenuated vaccine, and the vaccine is actually tested that you don't give titers above 3 logs in a midge, in an animal before it's released. So if your virus titer in the animal is 3 logs, the chances for a midge to pick up a virus is very low. But still, it also means that there is still a chance that the virus, that the vaccine can pick up that the midge can pick up the vaccine virus, and that's why also you mustn't vaccinate in a high midge or a high vector period. Because with 1 million midges around, doesn't matter how little of them, how few of them become infected or pick up a virus, even a very small percentage of a million can still be quite a number of measures. So your chances will be low, but there's still a chance. In vector control, as with most insects, we only see the adults flying around, and the adults is actually causing the problem. But as I say, with most insects, the adults form less than 5% or 1% of your total population. If you kill 1% of your adults, or you won't even manage to come near to killing 1%, or your adults, you still have thousands which can fill its place. It's like the old saying, if you swat one fly, 10 or 20 will come to the funeral. So there is still, that is a true story. And despite of that, most control efforts for the chilicoides and most insects are still actually aimed at the adult stage. There's a lot of talk about climate change and climate warming. If we look at the life cycle again, chilicoides are cold-blooded, so their temperature, their life cycle is very much dependent on temperature, and of blood feeding and the development of eggs, the whole life cycle actually will be much quicker and much quicker, faster at higher temperatures. Your periods between blood feedings will be higher, more frequent. Feed on blood more frequently, and also in the virus side or in the animal side, the virus will grow much quicker to higher titers at higher temperatures. So there will be more meats, they will feed more often, the virus will be of higher titers in the meats. So it's not to say you don't have a linear increase with climate change or higher environmental temperature. It will be more logarithmic increase of an exponential increase in your risk of transmission with warmer temperatures of atom. And that can also perhaps explain, or partly explain, why most of your horse sickness outbreaks is at the end of summer, when the temperature is highest and there's already big populations of meaters. Okay, so if we think of control once again, high vector abundance renders that you must concentrate on integrated control methods. You mustn't think of what one single method will be able to get rid of your meaters. And you must look at the problem and the disease and the vector, of course. So, vaccination still stays a safe option. Treatment of breeding site reduction, biting rate reduction, everything you can think of must be incorporated in possible control. Just a very general representative of what integrated control must be, but you must look at environmental management, chemical control, biological. As I say, the more of these factors you can combine into a single control method, the better. And integrated control methods comprise of chemical, biological, and environmental procedures used jointly or sequentially against a background of a comprehensive ecological understanding of a selected target. So, understand your target, know your enemy once again. Methods must be fully acceptable from a health and environmental standpoint, and the success of any integrated or any control program and disease risk analysis will depend on the ability to detect all the potential vectors in your area. As I say, you must know what vectors are present, then you have a chance to control them. And with 1.5 million metres around per night, you can't even start thinking of controlling and reducing your populations at that population sizes. So you must actually try to concentrate and think more of methods to reduce the biting rate and the contact between your animal and your vector. Let's look at safe stabling or stabling. From all the years, it is accepted that if you stable your horses at night, it will be safe against African horse sickness. That is accepted, and the Europeans have done, and they've actually found that chilicoides can enter into stables, and that it will happen more in winter. So, let's look at the stabling. As I say, in South Africa, it's accepted for long that horses that are stable at night are safe, but actually, nowhere can you find what is defined as a safe stable. And also, on top of that, not much is known about the factors that attack livestock-associated chilicoides species. It can be, say, carbon dioxide, octanol, but very little studies has been done on what attack chilicoides to animals and what the entering behavior of these chilicoides into stables may be. And as I say, in Europe, it is shown that chilicoides will enter stables. Also in South Africa, it's actually very difficult to find a chilicoides-free stable. Even the best of stables, if you put a light trap, you will find some chilicoides inside the stable, much less than outside, but still it is not safe to clearly define or to say you've got an insect-free stable or a chilicoides-free stable. But if you look on the internet, all these will qualify as stables. Even this, which is more than just an off-duck, well, people will say, that's my stable, if I put my animals there, they will be safe. And you can see for yourself that, I mean, with that big openings, the chilicoides won't even notice that there's a stable. So, but this about the shortcoming in the work, what is a safe stable, and what is the minimum requirements for a safe stable. If you look further, in the more professional setup, there's people who are using negative room pressure and positive room pressure, with a fan, a double door system, with a fan, which can suck chilicoid, your doors closed, and air is sucked inside and blown out through the roof, and there's a build-up of volatiles away from the entrance. So fresh air is sucked in through a double door system or through a door system, and I mean, you open the door, enter, close the door, in. Before that, and then you open that door and you enter the stable. So that's the most common system used in South Africa. A better system may actually be positive room pressure, where the air is sucked in through a filter. No, this is one most commonly used, where the air is sucked in through a filter and blown out at the doors. But like you see in this case, you have a build-up of volatiles and chemicals which may attack chilicoides at your entrance. In this case, the build-up of volatiles and the pheromones which may attack the chilicoides is away from your entrance doors. Fans, as you see, the chilicoides are relatively small, they are weak flyers, they can't fly very well, so fans will definitely help to keep them away from your animal. And the fans will also disperse the chemicals, which may or may not attract chilicoides away from your animals. Other systems that people look at, and work up to a certain level. The most common one, a plastic curtain, air curtains, and interesting work that was done by Biogens in Germany the last couple of years for mosquitoes, is that an electrical grid system with positive and negative plates, which were installed there. They tracked it on the one side, they released mosquitoes on that side, and they tracked it on this side, that the mosquitoes won't pass that grid. So that is something which we can look for at chilicoides, but that's all. It's not a very high current, it's very safe actually, and that's something we have to look for at chilicoides and see if it will work. Okay. There's we have included the grid system. Another control effort which was used over the years, or what's actually suggested for Blue Town, which was in the KwaZulu-Natal farm, the people have got Blue Tongue every year, and when somebody suggests that we must keep cattle outside or close to the cattle, close to the sheep, and half of your chilicoides feed on the cattle, and actually reduce your biting rate of the sheep, and the incidence of blue tongue has actually dropped, and they didn't have any case for blue tongue for the next 5-10 years. But as I say, although this method was so successful, it is also controversially, because cattle can form the breeding sites for the Chilicoides pollutinus, and the biomass on your farm can actually increase, which will increase the total number of Chilicoides, and actually increase your biting rate and the burden of Chilicoides. So, but as I said, in that one case, it did work, and there's not much more work done on that.